Now we cross over to our OCR for Global Insight and an in-depth look at important developments in world affairs.
Thanks very much, Mark. It is indeed time for Global Insight, where we speak to experts from around the world on issues making headlines. Now, fears that a new 5G service in the US could ground airplanes and cause travel and logistics to grind to a halt have now dissipated. There have been warnings that a new C-band 5G technology introduced by US telecom companies could interfere with critical flight instruments, such as radio altimeters, which help estimate the distance from the ground to the bottom of the vessel, becoming crucial in low visibility operations. While the crisis appears to have been averted, we discussed just what was going on, why it happened, and whether it's the last time we hear of this problem. For this, we have Rob Pegoraro, freelance technology journalist who writes for USA Today, Fast Company, PC Mag, and other sites. We're also joined by Tommaso Melodia, director of the Institute for the Wireless Internet of Things at Northeastern University. Very warm welcome to you both. Let's start with you, Mr. Pegoraro. Sorry about stumbling there over your name.
No worries.
Well, it seems that the worst of the crisis is over. So are flights in the US back to normal now?
They seem to be, or as normal as they can be, given we also have the coronavirus causing a lot of crews to be out sick. There are still issues, certainly with airports where you have lots of fog or weather that would require landing on instruments. And certainly, I'm looking right now at the Federal Aviation Administration site, that they're saying 90% of the U.S. commercial fleet is now cleared to operate in and out of airports near markets with C-band 5G signals active. 10% is still a lot.
I see. And, well, Professor Melodia, now, the crisis does seem to have been averted, but what really was the root cause of the problem?
Yeah, thanks for having me. Wireless communications clearly rely on using electromagnetic spectrum, radio waves, to carry information, right? But use of the spectrum is regulated worldwide. You can't just transmit whatever you want. And in the US, the Federal Communication Commission, or the FCC, regulates the use of spectrum and sells rights to use portions of the spectrum to various commercial entities through auctions. There was an auction in 2020 for a significant chunk of the 5G spectrum in the so-called C-band between 3.7 and 3.98 gigahertz. That's a portion of the spectrum that was not used for cellular communications before 5G. And the FCC had been doing lots of studies in the past few years to determine whether the C-band could be used for 5G, and they concluded that it was safe to do that. Now, various companies bid $80 billion to the FCC to acquire the licenses to use that portion of the spectrum, right? And AT&T and Verizon specifically bought a good part of the spectrum, and now they want to deploy their 5G network in the C-band, which is clearly precious real estate for them. Now, here comes the problem, right? That there's radar altimeters that are used in the airline industry for automated landing that operate between 4.2 gigahertz and 4.4 gigahertz. That band is reserved for them, right? Now, in a technically ideal world, you will have no problem, right? 3.7 to 4 gigahertz used by 5G, 4.2 to 4.4 used for altimeters. You have different frequency bands. 5G operates in its lane, and there's a few lanes in between that are empty to avoid spills of energy between the two technologies. Because the aviation altimeters operate in a different lane. Everything is separated, everything is nice, except for some of these old altimeters were not designed with the specifications that are required today to make sure that they don't get any interference from 5G. The old altimeters are using a larger portion of the spectrum than they should. And it's no one's fault. They were designed that way because at the time, there was no 5G to be aware of. Now, the separation between the 5G band and the 4.2 gigahertz band where the altimeters are, that's pretty wide. It's 220 megahertz. It's big. It's like 10 Wi-Fi channels, okay? So it's a wide gap. The problem is that the filters in these old altimeters are such that the signal might spill out of their lane. So the radars could be getting signal from a wider band, including 5G interference. Now, what happened is that there was a study from an association close to the airline industry in the US that claimed that theoretically there could be spills that could impact altimeters. And this was before the FCC auction. But the carriers and the FCC contend that this study is based on overly pessimistic assumptions that do not hold in reality. So it's hard, the problem is it's hard to come up with an independent evaluation because there is lack of cooperation. And folks either don't have the 5G base stations, the altimeters, or the deployment specs that would be necessary to come up with an independent evaluation. I would say that really dangerous interference is unlikely, but still in the current situation where nobody knows if and how many altimeters are affected, we're probably going to continue to see limitations close to major airports.
Oh, Mr. Pecoraro, well, the question is, why wasn't this problem thought of before, and what kind of lessons do you think we can take away from this whole 5G airline crisis?
That is the real mystery around Washington. At the time the spectrum was getting freed up, the offices of the FAA and the FCC were about a 10-minute walk from each other in Southwest DC. But for whatever reason, part of it seems the FCC was very intent on getting as much 5G spectrum in use to win the race to 5G, which is sort of a silly concept. And the FAA just did not sort of get checked into this discussion when it should have, because yeah, there's a huge diversity of not just commercial airplanes operated by airlines, medevac helicopters, general aviation, a lot of hardware out there that you can't just assume is going to work. And the FAA's presumption is rightly, we're not going to assume that this is safe, prove it. We have a culture of safety. Every day we figure out, can we make the system a little safer, not just stand pat and think it's all fine. So there was a big breakdown in people who should have been talking to each other and comparing notes. Hopefully that won't happen again. I'm sure that there's a lot of embarrassment among all the parties involved because, yeah, it's a huge mess where you worry, I have a flight Friday, which I think will be fine. At this point, I'm more worried about the weather than C-band 5G, but it should never have gotten to this point.
Well, Professor Melodia, what else does the 5G rollout affect other than commercial airlines? What other signals or systems should be considered or addressed before 5G is further rolled out?
Yeah, well, so 5G is already being rolled out worldwide in a number of mid bands and high frequency bands. From a technical point of view, there's a number of techniques that can be deployed to guarantee safe and fair coexistence between 5G and other government, military, and commercial services, right? Including better filters, more restrictive spectrum masks, even a number of very sophisticated spectrum sharing techniques. So it's a matter of having the right conversations, having policy decisions at the right time, rather than really a technical problem. Then, going forward, there's going to be a lot of technologies that will enable sharing of the same spectrum bands between different services. My research group has been developing spectrum sharing techniques based on artificial intelligence that guarantee coexistence of cellular systems and Wi-Fi in unlicensed spectrum bands. And this will be applicable to other coexistence problems as well.
Mr. Pecoraro, now, how reliable and fast is 5G as a network? We've had the 5G rollout here in South Korea. We were the first in the world to commercialize this, but there have been questions as to, yes, how fast it actually is and whether it can, work as well through buildings. And there's been some questions around that. So how reliable is 5G?
It's very much three flavors. The one you're most likely to see and least likely to be impressed by is low band 5G, which is on the same frequencies you get 4G on. So it's not a huge upgrade in speed. You may find it's actually slower than 5G. All three carriers, to a certain extent, have millimeter wave, which is extremely high frequencies. It's incredibly fast and it's incredibly hard to find. I have walked up and down city blocks where it's supposed to be available and found no millimeter wave signal where the carrier's coverage map says you should be online right here. In the middle is mid-band, and C-band is part of that. That's AT&T and Verizon. People who now have it have been very impressed by how much faster it is. We're talking hundreds of megabits per second downloads. T-Mobile has a different batch of mid-band, which has been available for much longer and is unrelated to this entire radio altimeter mess, which is also very fast. People seem quite happy with that. But yeah, for most people, I would say in the US, 5G has been a disappointment because they only get this low band flavor. C-band has the potential to make it much more real for a lot of people, and also to give a lot more people a choice in home broadband. They can sign up for fixed wireless 5G from one of the carriers instead of being stuck with their local cable company.
Well, Mr. Pecoraro, now there's been a lot of hype over the whole 5G network in terms of what kind of services it can provide, how fast it is, how, what little lag time there is. In what ways has the industry hyped 5G too much?
It's been so unhelpful. You see people, executives who should know better, stand up at telecom conferences and say 5G will make self-driving cars possible. It certainly will not. There's no way a car will get approved for operation on the public roads if it requires a network connection. They'll suggest it would make robot surgery possible. Could be. Half the time when people say 5G will make this happen, they're just saying if you had a fast wired connection and good Wi-Fi, you could also do this. And I think it plays into a lot of disappointment when people get a 5G phone, use it and think this is pretty much like my 4G phone. What's the big deal?
Well, I don't want to be too biased, but I've actually turned off my 5G and I'm just using LTE. But anyway, Professor Melodia, now there are also some concerns about cybersecurity as countries around the world, they continue to build up smart city infrastructure and systems based on 5G technology. What are some risks that we're going to have to deal with, and how should they be mitigated?
Well, right, yeah. So 5G and the Internet of Things, that is a technology associated with 5G, right? This idea of connecting all sort of smart objects and infrastructure. Indeed, a fascinating technology because it's not only a communication technology, but it can really create this distributed and untethered interface between the physical world, right, where we live and operate, and the digital world where all our data reside. That means basically two things, right? You can collect a lot of data and extract meaningful information from the physical world, and you can make better, more rational decisions on the physical world, but also we can act on the physical world, right? And for example, will someone be able to take control of an airplane by leveraging a cybersecurity vulnerability, right? And to stay on the topic of landing systems, some colleagues here at Northeastern University a couple of years ago published a study where they investigated a vulnerability of aircraft instrument landing systems to wireless attacks, right? They were able to spoof landing systems radio signals using commercial radios and causing things like last-minute go-around decisions and even missing the landing zone in low visibility scenarios, right? This was all simulated and nothing in a real systems, but clearly there are serious issues, right? That can be solved with a one-size-fits-all solution, where you require industry, regulators, and academia to work to develop best practices and solutions. Right.
Right. Well, Mr. Pecoraro, now what other urban infrastructures should we consider and safeguard as we continue to roll out 5G?
So with a lot of U.S. cities, there are lots of smart cities projects that get talked up and then never really sort of pan out. So 5G figures into that to a limited extent. I talked about millimeter wave 5G. There, to me, the more interesting part, to make millimeter wave work, because it's such short distance. We're talking like 1,000 feet outdoors. You have to run fiber optic internet all over the place. So once you have that on every block, then a lot more interesting things become possible. And that said, a lot of U.S. cities, we need to replace our existing analog infrastructure before we get too hung up over building digital infrastructure all over the place.
Well, I'm afraid our time is up today, so this is where we'll have to leave the conversation. That was Rob Pecoraro, a technology journalist who writes for USA Today, Fast Company, PC Mag and other sites in the US, and Tommaso Melodia, Director of the Institute for the Wireless Internet of Things at Northeastern University. Thank you both so much for your time today.
Thank you.
Having us. Thank you.